Hello, I'm Professor Chad Jenkins from the University of Michigan, where I'm in the Robotics Institute and the Computer Science and Engineering Division. It's a wonderful opportunity, a privilege to speak to the Democratize AI conference, at least virtually. And what I'm going to talk about are some of the things that we need to be doing in artificial intelligence, not just to advance all the technological and scientific capabilities, which is a marvelous privilege to be able to do and see it go out into the world and do amazing things, but also the things we need to do to get our intellectual domain right. And so that the technology we develop, the understanding that we generate, will actually have a positive impact on the world. And we can see some of the troubling trends we're seeing with respect to AI's use with Black lives, because if you're not providing equal opportunity and fairness for everybody, you're not really providing equal opportunity and fairness for anybody. And so I'd like to start off and just talk about the Black in Computing letter this summer. This was a letter that I helped write this summer. It was sparked by all of the issues that we're seeing across America, and with the killing of George Floyd, Ahmaud Arbery, Breonna Taylor, too many others. And so this is really something that has impacted a lot of people. And just brought, and made us re-examine what we are as a society at the core and how we need to do better. But this talk of how we can do, when we think about George Floyd and the passion that it brings out, it's still very detached from what we feel as computer scientists or AI or people who work in AI. But there are examples that we have to really think about. And I would talk about a very troubling story that came out just after we wrote this letter. That talked about the story of Robert Williams, so this happened actually earlier this year, January 9th, 2020, my 46th birthday. And I could tell the story myself, but I think it's better if you heard it from Robert Williams, and who was wrongfully accused, and his family, and how it affected them.
They came to the door. I answered it, and they kind of stuck their foot in the door and said, "Send Robert out." And I said, "He's not here." They said, "We just saw him come out of that van." And I said, "That was my mom. He's not here." I pull in the driveway here, hop out. By the time I closed the door, the car is in the driveway blocking me in. As soon as he shut the door, they were right on him, and they were already starting to cuff him by the time we get out there. I was completely shocked and stunned to be arrested in front of my daughter, in front of my wife, in front of my neighbors. I can't really put it into words. It was one of the most shocking things that I ever had happen to me. So when we get to the interview room, the detective turns over a picture of a guy, and he's like, "So that's not you?" I look. I said, "No, that's not me." He turns another paper over. He said, "I guess that's not you either." I picked that paper up and hold it next to my face. "This is not me." I was like, "I hope y'all don't think all Black people look alike." And then he says, "The computer says it's you." Hey, Julian. Julian, do you know why Daddy got arrested?
Because I looked it up on the computer.
Man, that breaks my heart every time I hear that. It's this is incredibly troubling, and this is something that we saw from our, we can see in artificial intelligence, that this false positive arrest, from a grainy video picture to recognize this person and have real world consequences. This is incredibly troubling, and it really brings home that we're not just talking about results from the lab or things that we talk about in an AI conference, or intellectual discussions we have about different algorithms and how they work. But this is a real consequence that happened to a real person, that we should be taking very seriously, especially if this becomes a trend. Mr. Williams, I feel bad for my field, and that you were arrested, you had to spend 30 hours in jail, you were hauled off and interrogated, You were, humiliated and embarrassed in front of your neighbors, your family, your close associates for no reason, for doing nothing wrong. And I think that's something that we should understand, that this capability has real consequences. I appreciated the opinion editorial that he wrote about that Mr. Williams wrote about facial recognition and why people were allowed to use it. But I think it goes even further than just the use of the technology. There's a deeper systemic issue. And that issue comes along with being able to say, how can you, arrest somebody from a grainy video where you can barely make anything out, and to say that this person here is somebody who we need to go take action on, so that's not just an issue of just misuse, but it's also sort of an inflation of what people think AI can do, and we've been building that hype up, and it's led to misuse. This grainy video is not just something that we're seeing as a misuse of police. There's also disputes that we have about how the technology works itself. So there was there was a big debate this summer about how you can use deep neural networks in order to take grainy video of, in this case, President Obama, and then turn it and then see the result and try to de-blur it or provide super resolution. It clearly mistook President Obama for somebody who he's not. And so these mistakes are going to have huge impacts. If it's doing this to President Obama, I can't imagine what it's going to do to just regular people. And this is not just new; it's been coming for some time. And so I want to just play a clip from Vice. This was 6 years ago. So it sounds a little ominous now.
Beyond that, there are things like facial recognition software that's now being combined with surveillance cameras. Probably the most interesting thing I've heard about is the linking of X-ray and infrared monitoring with surveillance cameras, so that these cameras can actually do something known as a virtual stop and frisk. It looks like we're going down the road of more and more surveillance in all of these cities.
And so that's 6 years ago, and that's and they're already talking about how much this technology is being used, and the issue is that we in AI have sort of let this hype just grow and grow and grow, and we need to be more responsible about it. But as I said, there's a larger systemic issue, because who's there to actually do the educating, and who's actually there to put the technology into use and see where it goes and provide that structure that's needed to bring the wisdom to our field. And so I would make the argument that not just AI has failed Mr. Williams in this case, but it has failed systemically. And so I'd like to make an argument that if you look at the AI research that we have very few and marginalized Black researchers that are in our field. So as the ideas are coming and taking shape, we don't have a diverse body of people there to be able to provide that wisdom at the ground level, at the foundation, about how this technology could be used and the different ways it could go, and that has an impact. But as that technology goes from research and becomes systems that go into deployment, that are purchased, and products that are actually used in the real world, we still have low production of blacks in those CS degree programs that could then go out into the workforce and see this technology grow and develop. And so we're seeing so the ideas are incubated, they're going off into the world, and there's very little diversity there to actually provide that wisdom. And then as that technology, goes into the world, there's really, unwise use of this technology by law enforcement, because we have, and not just law enforcement, but it could be anybody who's putting this technology to use for a number of different reasons. I raised law enforcement because that's where the issue happened with Robert Williams, and most people will actually do, I think, right by this technology, but we have to be concerned about, even if there's good intentions, the ways that could go wrong, even if there are even if there are, you have people that are, that 99% of people that are in law enforcement are trying to do the right thing, and I believe that's true. You still have to be aware of the abuses and how they can happen. And so there's excellent work out there that has looked at what I would call this front end problem about the use of the technology, and so so I would defer to the great work that's going on in algorithmic fairness and thinking about the biases that creep up in this technology, and so so there's a lot of work that's being done, or it's a growing area of work that's happening on the front end. I think more about what I consider to be the back end problem, which is what's happening in AI research and the systems development that is actually leading to these systemic issues, so that we actually can bring more people in, have more diversity when we're thinking about the next generation of AI technology. Because neural networks, if the trend continues, neural networks will come, it will rise, it will leave, and there will be something else to take its place. And so we need more voices in the room. We do that. We just need diversity across all dimensions, and that diversity that we have from the classroom and the research lab will naturally flow into the workforce, and so we can start to address things there, because our world moves very fast. And one thing that's actually at issue with this is that the technology that's used by AI is becoming more and more rapidly available for people to use. You can set up something that looks really good in terms of a deep learning system to be able to detect people, perform activity recognition, spot anomalies, and all these things. And on its front, this looks great. These results look pretty amazing, and it's something that you can just get off the shelf and put into action pretty quickly with some effort, but you can do it. But that actually is that sort of illusion of competence can create some really bad issues. But let's talk about how this actually works. For those of you who might not know how it works, and that what we're really doing a lot with neural networks is you have some sort of input image, which I'll call let's say some variable X, something X, and you're going to output some recognition. That would be your output Y. That would be like, hey, I see this thing or this type of recognition. And so we can think of the AI process in this form as a good old function, Y equals f of X, that we should remember from high school algebra. But in order to make this work, we need a lot of data. And we know that, so we know that the type of data we get, for an image, let's say, if we want to do recognize from an image, we collect all sorts of images, our training data of examples of every possible outcome that we could think about, and we just collect as many possible cases as we can. And this actually is pretty big business, in that that now the issue is the people that have, or the entities that have the most data, the best data, the most curated, most accurate, most representative, most plentiful data now can do the most with artificial intelligence. And so this is big business all over the world. But once you have that training data, you can then take it and then update a neural network structure using your favorite, optimization algorithms, stochastic gradient descent these days. I'm sure there's maybe still people using back propagation from way back when. But once you've trained that model up with all of your data, you can then take some new image, run it through your network, and get training examples. You can get predicted recognitions that work pretty well. But pretty well may not be good enough, because if you look at that data, if you look at what comes out of that, you'll just notice that ain't right. It just ain't right. And so one issue that you're going to have are false positives. So for instance, you have examples that are cars that are labeled as bus, and so you're going to get a few of those false positives, or something that shouldn't be recognized that is recognized. But the bigger issue is that you're going to get a lot of false negatives too. These are detections that don't fire but are actually there. And so you get all of these, there's a bunch of mistakes that are happening. And there are a number of problems that we have to still address for these types of AI systems. One is, how did these mistakes occur? An issue we have for neural network-based systems is that we don't know when it's right and when it's wrong. We have to just trust that it's right most of the time and have some way of dealing with it when it's wrong. But we may not know what that is or when that occurs. And when a mistake does occur, how do we fix it? How do we rectify one of those mistakes or recover from it? But the big issue in my mind is, what is the cost that's going to be paid when a mistake occurs? Who is that going to cost? Somebody's, going to impair them financially, emotionally, maybe even in terms of their health, or their life. And so we have to start thinking about what this cost is going to be. And I don't even want to think about what it could be at even bigger scales than that. And so we have to really have that discussion. And it's something that we face in robotics as well. So this is just research from my group. This is in our computer science building. And so our robots have some of these unstructured environments that we want them to work in. And so we want robots to be able to recognize various objects, like that's an object that goes to the laundry room, and be able to recognize it in clutter and unstructured situations and be able to work with those objects. And so one thing that we encounter just looking in our laboratory environments, just anecdotally, I would say from experience that neural networks are about 80 to 98% accurate. I wrote this slide a couple of years ago. Maybe I'd be able to up that to 99% accurate, right? And so if we just run one of these detectors, we look at it and it's like, that looks pretty good, but that ain't right. And then we have false positive detections in terms of spray bottle that's not actually a spray bottle, a detergent that's not actually there, sea salt somewhere that's not actually a salt container. And we have false negative detections of things that should have been detected that aren't there. We're academic research labs, so we probably could do more to make it better. But I would make the argument that even if you kept training and you try to make it better and better and better, the idea of getting 100% accuracy is an illusion. It's going to make mistakes at some point, and you got to be able to know when that's going to happen. And so one of the things that we've been working on are in terms of our methods, are ways to deal with that, to take neural networks for what they are. Something that has great recall power, excellent speed, but use that as just a guess, and don't take that as the absolute truth, and don't take that as the real thing. And so these are some of the results that we've got from the IROS paper that appeared at IEEE Intelligent Robots and Systems in 2019, and we showed promising results. And the way that we're actually trying to do this is get the best of both worlds, get the best of neural networks in terms of giving us guesses for how we might recognize objects and localize them, but then combine that with a probabilistic inference, generative inference, that allows us to maintain probability mass, so that we can say, so in case something isn't right, we've got other guesses that might be probable as well. And so we try to so this form of generative discriminative inference is trying to combine these two ideas together. People in these communities don't. So we depend on geometry for this type of inference, and people don't like using geometry now. They say, well, you're dependent on particular geometric instances. But I would say that that's a good check, right? We should not give up on geometry, because we need something to validate. We need something real to hold on to, so we don't make these very bad mistakes. But if you're using geometries at the whole object level, that can be problematic. So what some of our recent research has done is said, well, instead of representing geometry for an entire object, we can break it into parts. And so maybe we can have reliable parts detectors, and then those parts detectors can then be used, and we can use templated geometry with that, and we compose it as inference in a Markov random field, where the recognition of each part is a random variable conditioned on an observation. And if we can provide efficient belief propagation, that we would be able to do inference in this case. So what you're seeing here is for tools, articulated tools. We would be able to use a neural network, train that neural network, recognize the parts of that object, and then use efficient belief propagation in order to converge the multi-hypothesis tracking so that we can get maximum likelihood estimates that match what we're seeing in the image. And so we can get robustness as well as good recall power. At a high level, I'll let this video play, but at a high level, what I believe is that the same way that neural networks had a renaissance through adding more layers, GPUs to make the adding more layers in the network, GPUs to streamline the computation and make it faster, along with massive amounts of data to train from. The way that had that revolution from neural networks being completely on the periphery of AI to now the mainstream. There will come other options that have that potential, and I believe belief propagation is definitely that. And if you think about the systems ways that we can do to make this better in terms of computational efficiency, energy efficiency, deal with these computational issues that will make belief propagation a competitive alternative to neural networks or a competitive complement to neural networks. I believe that's where we're going next. And so given that, I think you can go read our papers, non-parametric belief propagation. I'm very much about that, and factor graph inference as well. But I want to come back and just add some higher level sort of thoughts on this. And that is, if we come back to this back end problem, this is something that we've seen throughout it's not just new, it's something that has gone throughout the history of AI. By the way, that's from that image over there is from the Viola Jones facial recognition paper. If you go and look at that paper, they actually are very diverse in terms of the faces they're considering. So I don't blame Viola Jones for this very much. But in general, we failed to include Black people in the advances of AI. I'm teaching my course this semester on robotics. I just covered A-star path planning, and where it was great to cover, the work of Nils Nilsson, who, I use A-star all the time. I owe a huge debt to him in terms of, and the work of a lot of the colleagues out of Palo Alto and Menlo Park for the great work that they've done. But in his recounting of artificial intelligence as a field, in this great book, The Quest for Artificial Intelligence, which gives a great history of artificial intelligence and how it's come about. There are zero, and he's just name dropping a bunch of all the people that were important players in the field. There are zero Black AI researchers cited. And that should say something about the foundations of what we have now, and we're seeing the effects of that. If we're looking at it in terms of from an American perspective, if we look at our population versus our workforce, there are some troubling trends. So minorities make up about 30%, 33% of the underrepresented minorities, I should say, make up about just over 30 to 33% of the population, but are very underrepresented in the technology domains in terms of the tech workforce. And this is what and this also applies for women as well, who are about half the population, a little over half the population, but 28% is probably optimistic. It's probably more like 20 to 25% of the technology sector workforce. And this is what we get to is we call a disparate impact. So even though there is theoretically equal opportunity for everybody to be a part of the workforce, we see these disparate impacts that basically show that there are disparate outcomes, and they're saying that there's something in the system that is preventing or not enabling underrepresented minorities to be a part of the advances and the development of the technology. And so it gives the appearance that everybody's welcome, but maybe that's not quite what we're seeing. And so that is where we're having some major issues in civil rights term called disparate impact. That disparate impact has a huge impact on the huge effect, I should say, on the quality of the work that we produce. Because if you don't have a diverse team, you have these underlying biases that you have just from your perspective. Everybody has bias, and so you bring those to the development of technology, and then that just impacts that just impacts the quality of the products that you produce. All you have to do is watch Silicon Valley, which was one of my favorite shows. Mike Judge is a genius. I just want to say that, and you can, and that just gives you some ideas about where you need diversity. Not just racial diversity, but diversity across many dimensions. So you don't get you don't overfit. And I use the word overfit to talk about neural networks as well. And so what can you do at the end of the day, right? It's great to think globally, but you have to act locally in the end. And so I gave a talk at the Robotics Science and Systems Conference a couple of years ago, 2 years ago, and I basically laid out what, the things that you can do, and I'll just repeat them here. And that is, if you want to eliminate these disparate impacts, you have to eliminate the double standards that are in our field. You should be looking at how consistent are you in terms of how you view your colleagues, your students, your applicants, understanding the history that has led up to this current time, and seeing, looking at it from a very sober perspective about why, are we really playing on an equal footing here? And you can see the output of that in terms of the diversity of the things that are around you. Is your research lab diverse? When you're citing people and when you're writing your papers, are you citing a diverse collection of people? Are you just citing people who just happen to be part of your social circle? Is when you look at your classroom, are you seeing a diversity in that classroom? Because who's ever in the class now will be the future later. And we all have committees and various things that we do professionally. And those things, and when you're seeing those people there, that is reflective of the field and who is defining what we're doing as a society. There's one thing I forgot, though, when I was talking about this, is that how diverse is your funding review meeting? Because at the end of the day, nobody does anything out of thin air. You need investment, investment in terms of money, the finances, but also people to invest in you in terms of their time and their willingness to engage. And so if you're not seeing diversity in your funding review meetings, you're probably not going to see it in our field. And I can tell you, I've been to any number of funding review meetings or conferences or various other events and been the only Black person in the room, which, and that's over my career as, 16 years plus as faculty and then as grad student as well. Nowadays I might be one of two or three out of hundreds or thousands. We've got a long way to go. And so what I would argue is that we should be incentivizing equal opportunity in computing. This is worldwide, but I speak more about what we should be doing in terms of. I speak more from an American perspective of the federal funding. American federal funding has a big impact on the field because America has been a leader and still is a leader in AI and the development of the technology. And we have certain laws that govern how we invest in organizations and in our future. And so the Civil Rights Act of 1964 effectively says that if you're receiving federal funding, that you cannot have disparate impacts. You have to be creating equal opportunity. You can't just say, you can't have just disparate treatment, which is explicit discrimination, saying we want these people and not these other people. But disparate impacts is also seeing that in the output, the systemic output is not something you can do with federal funds, and also prohibits by anybody employment discrimination. So you can't discriminate somebody against their color, race, sex, national origin, and so forth. And I can say even and there's been a number of gains that we've had in civil rights over the decades that have had great positive effects on our field. I can say that we had Title IX in 1972, which basically said that if you're in higher education, if you're an institute of higher education, you had to provide equal opportunity, equal experiences for across the sexes. So you can't have some opportunity that's just for men. There has to be the same opportunity for women, or at least something that is equivalent. And so we think about that in terms of and usually in America, we think of that in terms of sports. You got to have if you have a men's basketball team, you got to have a women's basketball team. But it also means in terms of educational opportunities, scholarships, faculty hiring, things like that. And that really has changed our academic landscape, that I think has made our field better. I know that my story in computing would not be possible without the women who were involved to provide me mentorship and guidance all throughout my career. And so I'd love to say, and this was signed by President Nixon back in 1972. Except this is actually not. He's not actually signing Title IX here. He's actually signing the Clean Air Act. I guess he wasn't good enough for him to get a picture of signing Title IX. But it's good that it's there, and I know it's had a positive impact. But at the end of the day, the thing that we should remember is that even just as much as the investment matters, empathy is something that we need. We have to understand that our technology doesn't just sit in a vacuum where we can think big thoughts and it never has an impact. We need our computing needs empathy, because our work is going to have real consequences. And speaking of consequences, I hope everybody gets out and votes. Wherever you are, please make your voice heard. We need that. We need that to happen. Thank you very much.